Okay, so this is chapter 1, section 6, and now we're going to be talking about transformations of functions. What we're covering in this section is really almost everything you learn in Algebra 2. We're going to look at all these different types of functions, and we're going to generalize how do we shift them up, shift them down, shift them to the right, to the left, stretch them and shrink them, and all the different things that we can do to functions. Now, this page is straight out of the textbook, and I think it's a really helpful chart for you guys. It talks about the domain and the range of these functions and gives you a general picture of what their graphs look like. So we have the constant function, the linear identity function, absolute value, quadratic functions, square root, cubic functions, and then cube root functions. These are not all the types of functions we'll see in this class, but it is a good general review of what you should know coming into it. Now remember, if you have a vertical shift and you add some value or subtract some value on the end, that's going to shift your graph up or down. Horizontal shifts are inside the function, generally inside parentheses, and it's the opposite of what you'd think. If it's a minus sign, you're actually moving to the right. If it's a plus sign, you're actually moving to the left. Now, vertically stretching and shrinking your graph, that's some coefficient out front here. And if that coefficient is larger than 1, the absolute value of it, you're stretching it or making it taller. If your absolute value is less than 1, then you're shrinking it or making it shorter. Briefly, I'm going to go through some examples of these different functions. So something where it's being shifted up, it would be like f of x is equal to x squared plus 3. Shifting down would be like f of x equals x squared minus 3. Shifting to the right and to the left would be something like f of x is equal to x minus 3 squared. That would shift to the right. F of x equals x plus 3 would shift to the left. Something to make it taller would be like f of x is equal to 4x squared, or f of x is equal to negative 4x squared. Something that would make it shorter or shrink it would be f of x is equal to 1 over 4x squared, or f of x is equal to negative 1 over 4x squared. And moving on to the next page, we can talk about reflections. So if I start out with a function, let's say this quadratic function right here, and I want to reflect it across the x-axis, you're going to multiply by a negative out front, okay? And then it'll flip down below here. Okay. And if we want to reflect across the y-axis, then we're plugging negative x on the inside of the function. So if I start out with something like this and I want to reflect it across the y-axis, then it reflects over this way right here. Okay. And these are just some examples here. And we can also look at horizontal stretching and horizontal shrinking. Now, if I have some c value inside my function here, you can probably see this better on your notes here, but if I multiply inside here and c is greater than 1, that's going to horizontally shrink my graph. And if our c value being multiplied on the inside here is between 0 and 1, so like a fraction, like maybe 2/3, then that's going to horizontally stretch our graph. Okay. And again, flipping the page, we have a summary of all the different transformations here. This chart can be really helpful to you. It summarizes everything that we've now talked about all into one chart. While you're doing your homework for this section, I would recommend having this chart out just so you can reference what's happening with different shifts on your graph. We're going to go through some examples now. Looking at our first example, we have the square root function, and it's been shifted. It's been shifted down 3. And so we're going to go ahead and graph that. Let's go ahead and set up our graph here. And the parent function of this graph would be g of x is equal to the square root of x. Okay, so I'm going to graph that first. And the square root of x, well, plugging in 0, we have 0. Plugging in 1, we have 1. Plugging in 4, we have 2, and we could go on to 9, and we'd get 3. And that's what this graph looks like. And then when we shift the graph down 3, we have g of x is equal to square root of x minus 3. And each one of these points is just going to move down 3 spots. So down 1, 2, 3, down 1, 2, 3, and down 1, 2, 3. And this is our new function. Okay. And this is our answer. You want to make sure you're clear as to which one is your answer here. And again, flipping the page, we've got a few more examples on the next page. So looking at number 2, now we have an absolute value graph, and we have 2 types of shifts with this graph here. Going ahead and setting up our graph here. We have a shift down 2, and then we're also shifting to the left, opposite of what we would think, 1. Okay, and our parent graph is h of x is equal to the absolute value of x. So I can graph that parent graph here, and I'll go ahead and do that in green. And I should see this kind of detail on your homework or on a test or a quiz. And each one of these points is moving down 2 and left 1. So down 2 and left 1. And we can see what our new graph is going to look like. And that is h of x equals absolute value of x plus 1 minus 2. We've got a couple more examples here to look at. Now we have a quadratic graph that we're going to be looking at. And again, setting up our graph here. Okay. And I'm going to stop graphing the parent functions just because I think you guys are starting to pick up on these examples here. So again, from the parent graph, it's going to be moving to the left 2 and up 1. And it's also stretching vertically by a factor of 2. It's also reflected across the x-axis. Okay. Now you know how to graph this function, so if you know that this is our vertex, you can go ahead and graph that. Our vertex is going to be -2, 1. So -2, 1 is our vertex. We know by the negative out front that it's going to be going down, and we know it's stretched by a factor of 2. If you're not sure how to graph it, you can always plug in points. You can plug in -1, and plugging in -1 is going to give us -1. Or you could plug in -3 and just choose some points to the right and left of the vertex. You're actually going to get -1 there as well. And we have enough to draw our graph. Now for our last example, we have a cubic function, and we're going to go ahead and graph that. The only shift that we're worrying about here is that it's reflected across the x-axis, and it is being shrunk vertically by 1/4. Okay. So I'm going to go ahead and set up our graph here. And we can go ahead and plot some points. And I'm going to actually plug in some nicer points here. If I were to plug in 2, so let's make just a quick table here. 2, -2. If I were to plug in -2, then I would end up getting +2. So we'll plot those points here, draw our graph, and now we are done with this section.